Welcome to MV Tutors. My name is Figa Manana, and today we will be doing the topic of proportionality. Proportionality. Okay, so if this is what you're interested in, then you came to the right place. But I like to start my sessions with a vision. So here I have a past exam question paper, which is our vision. It's what we are working towards. Now, before we answer these questions, we need to learn the principles that are needed in order to, answer such questions. And that is exactly what we'll be doing. And at the end, we will apply those principles to answer these questions. Okay, well, without any further ado, let's get right into it. Okay, let's start right here. We always have to start with triangles with this topic. So we have a triangle right there. Okay, if we have one triangle there, and let us say we draw a line to make two triangles, a triangle within a triangle. So we have A, B, C, D, and E. Okay, so this consists of a small triangle, right? If you look at it, that small triangle, which is A, B, C, and then it's the big triangle, right? The big one on its own. Okay, I just want it on its own, and it is A, D, E. Okay, let me just bring this down a little bit. Cool. All right, so if we look at these, so this big triangle is a triangle within a triangle, small within big. Now the proportional theorem, I don't want to prove it, but I just want to show it to you so that we apply it. Basically, we can say it says AB. Okay, if we look at AB, proportional, remember proportional includes portions, so there's got to be two or more portions of it. So if you look at AB and you say AB divided by, that's the small one, divided by the big one, that is proportionality. So on the big one, you have to choose the exact same side. Okay, so this, now we are looking at it, rather, let me just start here. Let me say two sides. Proportional, two sides. Let me put the word proportional. Proportional, two sides. It says, okay, AB divided, so that's AB divided by AD on the big one, is equals to AC divided by what? Divided by AE on the big one. Okay, and it's equals to BC on the small one divided by DE. Okay, but that's not all. That's not the only configuration. There's another one where you can actually take two sides of the small one instead of one side and equate it and proportional to another side of the big one. But you can take two sides now. You can then say, let's take AB divided by AC on the small one, two sides instead of one side. That is proportional to AD divided by AE. AE, like that. Okay, two sides, taking two sides, we can also take AB and divided by, let's say, BC, and that's proportional to the big one, which is AD divided by DE. Okay, and also you can also say from the small one, I take AC and BC, so I can say AC divided by BC, that's equals to AE divided by DE. Okay, so all of these is proportionality due to sides. So you can do the one-sided one, okay, because this is one side. We used one side to do these ones, okay, and to do these ones we use two sides, right? Okay, we use two sides of each triangle. So that's a proportionality theorem. But also we can do the same due to we can do proportionality due to angles. Okay, let me just do that real quick on top here. Let's say proportional due to angles. Proportional due to angles. So how do we look at this then when we are actually looking at angles? What we say is that, okay, looking at angles, we say triangle, the angles are angle A is equals to angle A on the big one. Remember, you always do proportion of small is to big, right? So you can say angle A, okay, is equals to A, and then you can say B is equals to B, I mean to D on the big one, and then you can say C is equals to E, right? So when you write the triangle proportionality theory, when you say these triangles are similar, you can say triangle ABC is similar to triangle. Now you have to put them in order, because if it's not in order, then it's not going to work. On the big one, remember ABC is the small one, and then on the big one you say A and A are the similar ones, angles B and D, so I should put D in the middle, okay, and then C and E are similar, so I put E here. Okay, this should be such that you can literally say from here, you can then, just using the similarities, you can say AB, just to use it practically, you can say AB over AD, see, is equals to, you're doing the proportionality, BC over DE. So some questions will just give you this and not the triangles, but from this similarity you should be able to do the proportionality. And then the last one is AC over AE. That's how it works. AE. Okay, so that's due to angles. Now, which one do you use? It's to the question. You know, the proportionality can be done in so many different ways. Okay, one more way, let me just show you one more way that you can do the proportionality. Let's say now you are actually given it's due to nothing, but let me just say based on this triangle once again, it's not just small triangle over big triangle, but you can also say small triangle over the smaller portion that's left, right? So you can say AB, which is this, over BD. You see BD, it's neither small triangle nor big triangle, but it's part of the big triangle. It's not the entire big triangle, but it's just BD. But when you do it this way, you then have to take the other side exactly as it is, which is AC over CE. That's something you can do as well. And then the last one is BC, which is that BC over DE. Okay, so this one now is just due to, you know, portions of the triangles. Now, as you can see, there are many ways to skin a cat. There are many ways to do the proportionality. Now, which one do you choose? You choose the one based on the question they've asked you and also the information that they've given you. You choose the most relevant one. Now, it does take a bit of practice to know which ones exactly, but essentially you should be able to see which one would be relevant for which questions. Now, these are the principles that you need to know about proportionality, which will help you actually answer questions. Now, what I want us to do is go right straight into the questions and try to apply these principles that we just learned. Okay, so here we go with the question. It says, in the diagram below, triangle ABC. Now, you should always look as you read for the triangle. So ABC, I see it, is drawn with D and with D on BC. Oh, there's D. And F and E on AC. F and E, I see them, such that AB is parallel FD. AB is parallel FD. Okay, I see them. And then BF is parallel DE. BF is parallel DE. Okay, thank you. And then also AB is perpendicular to BC. AB is perpendicular to BC. Okay, it's been shown as well. Furthermore, CA is 13 units. CA, okay, there we go. And CB is 12 units. CB, all right, I see them. Now, what's the question? Let's start with the first question, which is 10.2.1. Write down the length of AB. Now, whenever I get these things, I always like to take out from the question, because you can see this drawing is actually very busy. So I just want to take out what is relevant for me to answer the question. Okay, so taking that out, I'll redraw the triangle just like that. Okay, like that. And then the one that I'm interested on really is, because they want the length of AB. So that's AB, so they want that length. So I'm taking out ABC and I put the relevant information. I got 12 there and I got 13. Well, look at this. What I have here, I can use Pythagoras to answer my question, because you know this is a right angle triangle, so I can use Pythagoras. Pythagoras says AB squared plus BC squared is equals to AC squared. That's Pythagoras. Okay, Pythagoras. Okay, so AB is what I'm looking for, right? So that's gonna be the square root. Now this is just mathematical gymnastics, okay? AC squared minus BC squared. Okay, I'm sure by now that you're in metric, you've used this so many times. Okay, AC is 13 squared minus BC is 12 squared. Okay, so we put this in a calculator. I'm not sure if I should bring in my own calculator or I should just put it in the head, but let me bring in my own calculator. So square root of 13 squared minus 12 squared. Let's do it like that. The answer is 5 units. Okay, so that's 12.2.1. and now they say prove stating reasons that triangle CPA is similar to triangle CFB. So whenever you get this question, right, which is what I was saying to you previously, that all you have to do then is take what you've been given. So this is question 10.2.2 A. They want us to prove that triangle CBA is similar to triangle CFB. Remember, I told you that you put them in order such that this angle should be equals to that angle in that big triangle, and then this angle, this middle angle, should be equals to the middle angle. The last angle should be equals to the last angle. Now I have to prove at least two of them. I need to prove two of them being equal, and then the third one will obviously be equal to each other due to angles in a triangle. Okay, but let's try. Let's see. C and C, how can I prove that C and C are equal? Well, okay, you know what? Let me just take these triangles that they are actually talking about. If we look at the drawing over here, okay, we can see that triangle CBA, where's CBA? CBA, so that's the big triangle, CBA. Okay, and then the other one, CFB, CFB. Okay, so it's this triangle, right? I hate it when it does that, but that's the triangle we're dealing with, and then the other one that we're dealing with is the big one itself. Okay, see, so we got two triangles, right? Okay, I don't mind now, and that's the small one. Okay, so that I just wanted to show you the triangles. But what we can say then here is that, well, angle C, that's not the color I want to continue with red. You can say angle C is equals to angle C. Why? Because it's common on both triangles. Okay, it is common. That's it. Now B and F, why would triangle B and F be equals? Okay, let me just say B is equals to F. Why would B and F be equal? Let's go look. Okay, so angle B is obviously from the big triangle and it's 90 degrees. Angle F, it's obviously from the small one, and we can see it's also 90 degrees. Okay, do you see that? Let me just highlight that. Wow, that highlight is so huge. It's not what I want, highlighter. I want the smallest. Let's see now what happens. Oh, it's still big. But anyway, you can see that angle F is also 90 degrees. So now when we come here, we're gonna say both are 90 degrees. Okay, let's go back to red. Both 90 degrees. Now we can then conclude that angle A is equals to angle B. Remember, this is the big triangle and that's the small triangle. So they are, well, we don't even need to prove them. We just say, you just need to say it's a third angle of triangle. Third angle of triangle is always gonna be equal if two angles are equal. Okay, that's it. Then to finish it off, then we're gonna say, if you look at the left, okay, we write them exactly as they are. The first one we proved was C, the next one was B, the last one was A in this triangle, and then it's similar to the first one was C, the second one is F, and the last one is B. You have to write them in this order. Okay, it's absolutely critical, and the reason is angle, we just proved angle, angle, angle. Okay, we didn't use sides. Remember, you can prove proportionality using sides or angles. Here we use angles, so that's it. Okay, now let's go to the next question. The next question says CF is equals to CB squared over CA. Okay, so let me just write this down. This is now part B. We want to prove that CF is actually equals to CB squared divided by CA. Okay, that's what we are working towards. That's what we want to prove. Let's see, what can we... Now, this is where I was saying to you that you take the part of proportionality that is actually relevant for that particular question. So now if we look at the question here, we have CF. Where is CF? Let's identify. CF is from the small triangle, but also we have CB. CB is from the big one, and then we have CA is from the big one. Okay, either you do that, or you can also use this, what we proved here. Okay, so for example, if we were to start with CF, we can say CF divided by the small one. The counterpart of CF is actually CB. Okay, so divided by CB is equals to, so if we look at the question as well, it has a CA, so we can say CA, CF over CB, so that was small over big, so we have to be consistent. We have to say small over big again, so we take CB over CA. So you see, I said you take what's relevant based on the question. So this is what's correct. It's a small triangle, just to be clear, small triangle over big triangle. Okay, and it has to, for consistency, you have to keep at this. Okay, so from this then, and the reason for this, you always have to state your reason. The reason we could do this, we can then say that this is due to proportionality. proportional theorem. The reason we could do this was because it's due to proportional theorem. Okay. Now, very often when it comes to proportional theorem or similar triangles, let me see, it's big and small. Okay, they are proportional. They are proportional. Okay, I'll just leave it at proportional because we've proved it on the red one here. We've proved it. So it stays like that, and then from there it's just mathematical gymnastics. Can clearly see that CB is then equals to, not CB, CF. If you look at that, you can see that CF is equals to CB times CB over CA, which is equals then to what we are given here, CB squared over CA. Okay, that's it. That's how you do that one. Nice and short and sweet. Let's look at the next question. Okay, hence determine the length of CF. Okay, so CF, that's cool. We can do that quickly. We can then say CF. This is now 10.2.3. CF is CB squared over CA, right? And then what is CB? Let's go to C. Do we have the length of CB? Definitely CB, we can see from this triangle, is 12. So we got 12 squared divided by CA. CA is 13. Now let's bring out a calculator. Let's put this in a calculator. So I got 12 squared divided by 13. There we go. Let's put it in decimal. It's around 11.07 units. 12 squared divided by 13. 11.07 units. Cool. The next one says prove, oh no, give the length of AF. Now where's AF? AF is, let me use a pen. AF is right over there, right? So how can I prove AF? Now look at this. I have CA, which is 13, and I just solved CF. Okay, so I can then do AF. So if you look at this clearly, then this is now 10 point, no, don't like that color. Let's go back to black. So this is 10.2.4 now. So AF, I can clearly see that AF is actually equals to the big one, which is CA. So CA minus CF, right? So CA is 13. CF is, we just proved it, it's 11. Let me just make it 11. Okay, so 13 minus 11 is actually 2 units. That's it. So AF is 2 units. Okay, now let's look at the last question. It says determine the length of FE. Oh, so now if we look at FE, that's AF. Let's look at FE. FE is that one. over there. Okay, it's a bit complicated to solve this one. It will take a bit of gymnastics, but let's see how far we can actually go with this one. I want to do it up here. Okay, so now we are looking at question 10.2.5. That's the last question. They want the value of FE. Okay, so here we need to look at the triangles again. Okay, so let's look at two proportional triangles. So let's DF BA. Let's start with the big triangle. Okay, so if you look at the big triangle, the lines that are proportional, you've got this triangle, and that one is proportional to that triangle due to these big lines. So let me just take them out so that it's clear. I've got a triangle like that, right? And separated, it's not so high, it's actually quite low, so it's low there. And then I've got C right over there, which is that C, and then the parallel lines is this one is BA, so I've got BA, and then this one is DF. So inside of, I've got D and F. Okay, and then the other triangles that are actually parallel, if you look closely here, just based on parallel lines, I've got BF and then DF. No, that's DE. Yeah. So if I draw that triangle there, it's going to be like this. Okay, so that one, it's still C on top of there, and then they're also separated over there. I'm just extrapolating what I need, and then I've got D, B this side, so that's D, that's B, and then this side I've got EF, E and F, just like that. So I'm just basically taking out what I need from these triangles. Okay, so that's what I need in order to solve this question. Okay, my two triangles, and the question that I've been asked is determine the length of FE. Okay, so I'm looking for FE. Okay, so let's start here. And what I want us to do actually is remember I said you take what is relevant and you try to solve what you don't have. Now the proportional that we'll do is will be based on the numbers that we have. So we have CB. Okay, we have the length of CB, which is 12. We have the length of CA this side, so definitely we can take those big ones. And then here, which other length do we have? We actually do not have the length of BD, but also we do not have the length of FA. Oh no, didn't we just solve the length of FA? We did, AF. So that's the proportionality that we're gonna take. We're gonna take big over these small lengths. That's the proportional that we're gonna take. Let's start with the red. So we're gonna say CB, actually it's CB, which is this, divided by, let's take the big one again, CA, and that's gonna be equals to the lengths that we have, let's say dB divided by FA or AF. Okay, and this, the reason we can do this is proportional theorem. Okay, proportional theorem, and you have to write the parallel lines. Okay, because here the parallel lines is DF. DF is parallel FA. Okay, just like that. All right. From here, okay, let's start putting in the numbers. What is CB? The value of CB. CB is 12. Right, so then we can say 12 divided by CA. Let's go check out CA. CA is 13. Okay, so we'll put that 13 over there. It's equals to dB. We don't have the value of dB, so we'll leave it as dB divided by AF. Didn't we just solve AF? I think we did. Where is it? AF is 2 units. There we go, right over here. That's why we solved it, so that we can use it. So it's 2. Okay, so then from there we can see clearly that if we are to make dB the subject of the formula, then dB will just be equals to 2 times 12, which is 24 over 13. Cool. Now dB is not what we're looking for. We're looking for EF, right? So we'll do the same configuration this side. We will say CB over CF. CF is equals to dB. All right, dB over EF, just like that. Okay, now we can let's put the numbers right away. Oh, and the reason we're doing this is proportional theorem. This is the proportional theorem, and the parallel lines here is DE. DE is parallel to BF. It's parallel to BF. Cool. So what is the value of CB? CB once again is 12. And then CF. What's the value of CF? Let's go see CF. We solved it somewhere. CF, there it is. It's 11. I'm not gonna put the decimal. I'll just put the full number, which is 11, is equals to dB. Now dB is 24 divided by 13 divided by EF. Now I just need to do some mathematical gymnastics. So what I'll do, if I make EF the subject of the formula, I bring it this side, so that EF now becomes EF times 12 over 3 is equals to 24 over 13. But if I cross multiply, it's gonna be 24 over 13, and then to get rid of the 11, I multiply by 11. To get rid of the 12, I divide by 12, so it becomes 11 over 12. Now let me just put this in a calculator straight away. Okay, so I have 24. Let me put the it's 24 over 13. I want to write it exactly as it is, times, let's do a fraction again, 11 over 12. My final answer is 22 over 13. Oh, wait a minute, I think they wanted it like this, 22 over 13. That's my EF. The reason I say they wanted it in fraction form is because they told us here that leave your answer in the form A over B, which is just a fraction. Okay, so there we go. You know, it took a lot of work to answer this question, but basically we used proportional theorem, and I hope you understood what we just did. But in the event that you didn't, I'm available to tutor you, so please contact me via my website www.mvtutors.co.za, or alternatively you can WhatsApp me on 076 312 1107. Now before you do contact me, please speak to your parent or your guardian, because remember, at the end of the day, they are the ones that are going to be paying for the tutorial sessions with me, so they need to be involved from the very beginning. Okay, other than that, that's it from me. I hope you understood, and I appreciate you.